Analyzing survey data, understanding categorical, numerical, and ordinal variables. Before we start this video, let me ask you a question. Have you ever filled out a survey before? Chances are, most of us have. Whether it's an online survey, a feedback form, or a survey conducted by a researcher or a company, surveys have become an integral part of our lives. Surveys are an effective way to collect data and gather insights about a specific population or group. However, to make sense of the data collected from surveys, it's important to understand the different types of data that can be generated from them. This is where the concept of survey data types becomes important. In this video, we'll explore the various types of data that can be obtained from survey-based studies, including categorical data, numerical data, ordinal data, and time series data. We'll also discuss how missing data can pose challenges for data analysis and the methods used to handle them. By understanding these different types of data, you'll gain a deeper understanding of how survey-based studies are conducted, and how the resulting data can be analyzed to provide meaningful insights. So, let's dive in. Categorical data. Categorical data is a type of data that represents characteristics or attributes of a particular population or group. It is typically expressed in categories or groups and cannot be measured on a continuous scale. Some common examples of categorical data include gender, race, political affiliation, and marital status. Other examples can include types of food, education level, or preferred mode of transportation. There are two main types of categorical data, nominal and ordinal. Nominal data represents categories that have no inherent order or ranking. For example, hair color or blood type are nominal categories because there is no natural order between them. Ordinal data, on the other hand, represents categories that have a natural order or ranking. For example, education level, such as high school, college, and graduate school, can be ordered based on the level of education. The difference between nominal and ordinal data is important because different methods can be used to analyze them. For nominal data, the most common method is a frequency table, which shows the number of observations in each category. For ordinal data, rank order correlation coefficients, such as Spearman's rho or Kendall's tau, are used to measure the strength of the relationship between the categories. Another method commonly used to analyze categorical data is a chi-squared test, which determines whether there is a significant association between two categorical variables. Numerical data. Numerical data is a type of data that represents numerical values or measurements. It can be measured on a continuous or discrete scale. Some common examples of numerical data include age, income, height, and weight. There are two main types of numerical data, discrete and continuous. Discrete data represents values that can only take on specific, distinct values. For example, the number of children in a family or the number of pets in a household are discrete values. Continuous data, on the other hand, represents values that can take on any value within a certain range. For example, height and weight are continuous values because they can take on any value within a certain range. The difference between discrete and continuous data is important because different methods are used to analyze them. For discrete data, the most common methods used are frequency tables and bar charts. For continuous data, measures of central tendency such as mean, median, and mode are used to summarize the data. Additionally, measures of variability such as range, standard deviation, and variance are used to describe the spread of the data. The choice of analysis method depends on the nature of the data and the research question. For example, if the research question is about the average age of a particular population, then the mean would be an appropriate measure of central tendency to use. Ordinal data. Ordinal data is a type of categorical data that represents values with an inherent order or ranking. Some common examples of ordinal data include education level, income bracket, and job seniority. The concept of ordinality refers to the idea that the categories or values can be ordered or ranked according to their level or degree. For example, education level can be ordered from high school to college to graduate school, and income bracket can be ordered from low to high. The difference between ordinal data and nominal data is that nominal data represents values with no inherent order or ranking, whereas ordinal data does. Understanding this difference is important because different methods are used to analyze each type of data. For ordinal data, rank order correlation coefficients, such as Spearman's rho or Kendall's tau, are used to measure the strength of the relationship between the categories. These measures indicate whether there is a significant correlation between the ordinal variables being measured. For example, if a researcher is interested in studying the relationship between job seniority and salary level, they may use a rank order correlation coefficient to determine the strength and direction of the correlation between the two variables. Another method commonly used to analyze ordinal data is to use graphs such as bar charts or histograms to show the frequency of each category or value. This can provide a visual representation of the distribution of the data and highlight any patterns or trends that may exist. Time series data. Time series data is a type of data that represents observations or measurements over a period of time. Some common examples of time series data include stock prices, weather patterns, and traffic patterns. Analyzing time series data presents unique challenges compared to other types of data because the observations are collected over a period of time, and there may be underlying trends, seasonality, or other patterns in the data. One challenge of analyzing time series data is seasonality, which refers to the repeating patterns or cycles that may occur in the data over time. For example, if a researcher is analyzing retail sales data, they may observe a seasonal pattern where sales increase during the holiday season and decrease in the off-season. Another challenge is trends, which refer to the long-term changes or patterns in the data over time. For example, a trend in stock prices may indicate a long-term increase or decrease in value. To analyze time series data, different methods are used depending on the nature of the data and the research question. One common method is moving averages, which involves calculating the average value of a series of consecutive observations over a given time period. This can help smooth out the data and reveal any underlying trends or patterns. Another method is exponential smoothing, which involves assigning more weight to more recent observations and less weight to older observations. This can help predict future values in the time series by taking into account recent changes or trends. Visualization techniques such as line graphs and scatter plots can also be useful in analyzing time series data, as they allow researchers to observe trends and patterns over time. Missing data. Missing data refers to observations or values that are not present in a dataset. It is a common issue in survey studies due to a variety of reasons, such as participants not responding to certain questions or dropping out of the survey before completion. Conclusion. In conclusion, this video has covered the different types of data that are commonly encountered in survey-based studies, including categorical data, numerical data, ordinal data, time series data, and missing data. We have discussed the defining characteristics of each type of data, provided examples, and explained common methods for analyzing each type of data. In summary, understanding the different types of data in survey studies is critical for producing accurate and reliable results. By applying appropriate statistical methods and handling missing data properly, researchers can draw meaningful conclusions from their data and contribute to the advancement of their respective fields. Thanks for watching.